So if you have certain elements, how can you group them together? For that we can use a set. So a set is a collection of well-defined and distinct objects, and each object is called an element. So a set is basically a collection of elements. So there are several ways of describing a set. Number one, the descriptive method. What you do is you just say, you just describe it in words. For example, if you want the numbers between even numbers between 0 and 1, we just say S is equal to even numbers between 0 and 1. So what is this S? It can be any letter we can use to represent a set. So method of listing elements. What are the elements inside? As we said, a set is a collection of elements. So what are the elements in this particular, if you describe it as even numbers between 0 and 10, the elements would be 2, 4, 6 and 8. So that's how we use the method of listing elements. And next is the Venn diagram. So what you do is you put all the elements inside and you use this particular notation. Use the name of the set and then an arrow pointing towards the Venn diagram. This together we call a Venn diagram. And finally, we come to the set builder method. So to look at the set builder method, this is the set builder notation. So if it specifies the properties of that all the members should satisfy. So let's say our set is X, S, and it's described as this way. So how do you read this? All elements of X such that, this particular symbol we call such that, and then we describe what is X. The set of S is all elements X such that X is a positive integer less than 100. That's how we do it. After the such that, we describe the set. So back to our notes, and we are talking about the same example, even numbers between 0 and 10. So how do you describe that? X is such that X is an even number and it should be between 0 and 10. Simple. So remember, X can be anything. It can be X, Y, A, B, anything. And also there is no one particular method of describing it as a set builder method. For example, we did the same thing. X is an even number and X is less than 10 and greater than 0. Another way, let's look. So same set, 2, 4, 6, 8. How can you describe it? S is a set of elements all X such that you can use both the vertical line or the column, such that x minus 2, x minus 4, x minus 6, x minus 8 is equal to 0. So what is this? If you look at this side of the colon, you see an equation. So if you have to solve this equation, what are the answers for this? If this whole thing is equal to 0, which means x minus 2 individually is equal to 0, which means x is equal to 2, or x is equal to 4, or x is equal to 6, or x is equal to 8, which gives you the elements inside this set. So that is another way you can describe it. So there's no one method, and then you can use different A, B, X, Y, anything for the describing a set builder method. Another particular example, if we have set A is equal to 1, 2, 3, 4, the set builder method would be Y is such that Y is an element of Z. This symbol represents the integers, and Y is less than or between 1 and 4. So here we did not use the equal sign, here we use the equal sign. There are different ways of describing sets. What are the 4 methods? We'll observe. Descriptive method, you just write it. Method of listing the elements, you put the elements and remember the curly brackets. It's not square brackets or normal brackets, it's curly brackets, and use the name of the set and equal sign. And Venn diagram, remember the arrow. And set builder method, use X or any particular variable such that, and you describe it. It can be described in several ways. So let's look at the regions in Venn diagram. So in Venn diagram, we have the universal set. Universal set is represented by this particular symbol and a rectangle. And within that, we put in the subsets. For example, this A is a subset, like just as we did before in a Venn diagram. So one thing to remember is that universal set does not necessarily mean everything. It just means all this subset, all this A, B, all these sets within are subsets of the universal set, which means all the elements that are contained within these subsets are part of the universal set. So that is what it means. So if this is A, what is A dash? We use A dash or A complement, which we call the complement set of set A, which is the region which does not belong to A, but within the universal set. Okay. So for example, if A is the yellow colored region, A dash or the complement of A is the blue colored region. So let's look at an example. So let's say A, set A are the multiples of 3 in between 0 and 1. So what method is this? Descriptive method. So listing element methods, what are the elements? 3, 6 and 9. So what is the universal set? So universal set is numbers between 0 and 10. 1, 2, 3, 4, 5 up to 9. Now as I said, universal set does not mean all the numbers, but it is just a portion of which A is a subset. See, 3, 6 and 9, 3, 6 and 9 are a subset of universal set. The complement set of A is A complement or A dash are the region in the universal set which does not belong to A, which are 1, 2, 4, 5, 7 and 8. So we looked at one subset. What if there are two? There can be two subsets, A and B. So two things to remember here is the intersection and union. Now there might be elements which are common to both of these. For example, if we are talking about the numbers between if A are the numbers from 1 to 10 and B is the even numbers from 1 to 10, there are some numbers that overlaps or so sometimes they may overlap, sometimes they may not. So when there is an intersection, when there is an intersection where there are elements belonging to both the sets, we use the word intersection. So intersection means the elements that are belonging to both. It should belong to both. Union is all the elements. If we consider the elements of A, the elements of B together we call union. So in this case, A intersection B, there are no elements that are common to both A and B. So A intersection, the symbol is intersection, the symbol, we use this symbol for union. So A intersection B is a null set. So what is a null set? Null set is a set where the elements are empty. There are no elements. It doesn't mean just 0. It means this. So a null set is an element, is a set where there are no elements. It's an empty set. So coming back, so there are no elements that are common. That means A intersection B is a null set. You don't have to write a null set, just the symbol is enough. So here there are elements that are common. Therefore A intersection B is not equal to null set. So let's look at a few regions and definitions. So what are the elements belonging to A intersection B? Elements belonging to both A and B. So what are the elements belonging to both A and B? This particular region. A intersection union B, as I said, are the elements in both sets A and B. That means all the elements in A, all the elements in B, this particular region. So the complement of A union B, we already know what A union B is, this. So the complement of that, excluding that, we get this particular region. A intersection B complement. So what is A intersection B? this particular region, the complement of that would give everything else in the universal set which does not belong to A intersection B. A intersection B dash. So the complement of B intersects with A. So this is B. So what is the complement of B? Everything in the universal set excluding B, this whole region. And what is A? This whole region. So what are the intersection between those two regions? This particular shaded area. The same to A complement in intersection B. The elements common to both complement of A and B. Right. So now let's look at an example. So what is the universal set here? 1, 3, 6, 10, 9, 2, 7, 4. All together is the universal set. So what is A? What are the elements of A? 6, 9 and 10. B, 2, 9 and 7. So what are the elements that belong both to A and B? Element 9, which is A intersection B, 9. A union B, as said before, is all the elements that belong to A and B. 6, 9, 2, 10, 7. Those that are outside does not count. So intersection union B complement is 1, 3 and 4. The A intersect everything excluding this particular region would come under A intersection B complement. And this A intersection B dash. So what is A? This is A. B dash, or the complement of B, is everything excluding B, whole region. What is left? 6 and 10. So this is 6 and 10. Similarly, A complement intersection B would be 2 and 7, this particular region. So there's also a relationship between the number of elements. Now, if there's a set B, we call this disjoint set. So if there's a two sets which do not have common elements, let's say the number of elements in this is n1 and the number of elements is n2. It could be any number. So as we can see, A intersection B is a null set. There are no common elements to both. So the number of elements of A, this is how you read it, number of elements in set A is n1. Number of elements in set B, n2. Which means the number of elements together, the number of elements of A intersection B will be n1 plus n2. So this is what we get. The number of elements in A intersection A union B is equal to number of elements in A plus number of elements in B. Now, what about the case where there are three? There are common elements belonging to both A and B. So let's say the number of elements only belonging to n1. Yes, the number n only belong to n1 is A is n1, belonging to both n2, belonging to B n3. So the number of elements belonging to A alone is n1 plus n2. Number of elements belonging to B alone is B is n3 plus n2. And we got this. We can see the number of elements in the A intersection B region is n2. So what would we get if we added all this? If we had A, number of elements in A, and number of elements in B, we will get n1 plus n2 plus n2 plus n3. But what we need is A union B. So what is A union B? n1, n2 plus n3. A union B is n1, n2, n3. But if we add these two, there would be an extra n2, right? So this extra n2 needs to be cancelled out. And what is n2? It's the number of elements in the A intersection B region. So we can write it as follows. It's the same thing, n1 plus n2 plus n3. If we add these two, it's n1 plus n2, that's in the number of elements in A, n2 plus n3, the number of elements in B, and subtract it once. The reason we are subtracting is because when we add these two, we are adding the region n2 twice. So what is n2? Elements in A intersection B. So the equation can be written as n A union B is equal to the number of elements in A plus the number of elements in B subtracted the number of elements in A intersection B. So this is to a general equation n A union B in A plus n B minus n in A intersection B. The reason I say general is because if there are no intersection elements, or if there are no elements that are common to both A and B, what would this be? A null set. What is the number of elements in null set? 0. This would be 0. This should give us this particular equation. So let's recap what we've learned at this particular point. So we looked at the regions, the universal set, the complements, and there are these types of sets where the could be null, or the intersection could maybe or not null. Looked at regions of the Venn diagram and how they correspond. Looked at a small example, and finally we came up with this particular general form to get the relationship between the number of elements in two sets.